Madonna there by the Beatles. Okay, we're going to do integrals that involve long division. So, one of the things you want to look at this, on this example 6 right here, is the degree of the top is larger than the degree of the bottom. And as you're learning these things, you're going to take the wrong approach sometimes. Like, for instance, if you broke this up, like we were doing in previous examples, okay, you could integrate that okay. You know, that would be a logarithm integral right there. But this one would be a pretty tough one to do. All right, so what we're going to do is we're going to do long division, and then we're going to see if we can integrate from there. So the idea we're going to do is we're going to take the numerator, x squared, I'm going to put a plus 0x there, plus 2, and I'm going to divide that by x minus 1. Okay, so long division goes like this. We do x squared divided by x, which is x, and we multiply, so we do x times x minus 1. So that's going to be positive x squared minus 1x. Then we subtract, and when you subtract, you can subtract in your head, or a lot of times I just change those signs and add. Okay, so that's going to x squared minus x squared is 0. 0 minus negative 1 is really 0 plus 1, so that's 1x. Then we bring down the next number, and then we divide again. So now we do x divided by x, which is 1, and we multiply. 1 times x minus 1, 1 times x is positive 1x, 1 times negative 1 is negative 1. Then you can subtract, which you can do in your head, or you can change the signs. So 1 minus 1 cancels, and then 2 minus negative 1. So you're doing 2 minus negative 1. That's why you're doing 2 plus 1, so that's 3 like that. Okay, so what you have then is you write this. This is your quotient, like that. So you would say that would be x plus 1. Then this is your remainder. That's a positive number, so you say plus 3, and then you put that over the divisor x minus 1. So that's what we're actually going to integrate, is that. Okay, so we're going to work on the integral from 2 to 4, definite integral of x plus 1, which that's easy to integrate, and then plus 3 over x minus 1, that whole thing times dx. Okay, so the thing about this is this won't even take any u substitution, which is kind of nice. So what we can do is technically, when we do the indefinite integral, we're really doing the integral of x dx, we're doing the integral of 1 dx, and then we're going to do 3 times the integral of 1 over x minus 1 dx. All those things can be done without u substitution. Okay, so let's just go ahead and do this then. So power rule, that's going to be x squared over 2. The integral of 1 is x, because the derivative of x is 1. And write down your 3, and this is a natural logarithm. So that's logarithm x minus 1, like that. So that would be the answer to the indefinite integral. So what we're going to do is we're now going to go ahead, is since we're working out a definite integral, we're ready to go ahead and evaluate this integral with using the fundamental theorem of calculus. So we're going to take this antiderivative that we got here. So we have 1/2 x squared plus x plus 3 ln x minus 1. Okay, then I'm going to evaluate this from 2 to 4. And we'll kind of go back and look at what this means graphically. Okay? All right, so fundamental theorem, remember we plug in the 4 into the antiderivative, plug in the 2, and subtract the result. So what I'm going to do is I'm going to do 1/2 times x squared plus x plus 3 ln of x minus 1. So I'm going to go ahead and plug in the 4. And you can get into some pretty heavy arithmetic sometimes when you're doing definite integrals. Okay, now we're going to do this part right here. So we're going to do 1/2 x squared plus x plus 3ln x minus 1. This time we're going to plug in the 2. So we'll have a 2 in all those positions like that. Remember, when we do the fundamental theorem of calculus says you do the antiderivative of the upper limit, which is 4, minus the antiderivative evaluated at the lower limit like that. So now we got to work with a lot of arithmetic. So let's kind of focus on that a little bit and just take your time, do it very carefully. So this is going to be 1/2 times 16 plus 4 plus 3ln, absolute value of 3, which is going to be 3, minus 1/2 times 4 plus 2 plus 3ln, 2 minus 1 is 1, so we'll have that. Okay, so we kind of go through and work this out. 16 over 2 is 8. So we're going to have 8 plus 4 plus 3ln 3. ln 3 really can't do anything with that. That's an irrational number. Then we have 4 over 2 is 2. So we'll have 2 plus 2 plus 3. And then when we do ln of 1, remember that's equal to 0, because technically this is log base e of 1, and e to the 0 is equal to 1. Okay, so ln of 1 is going to be equal to 0. Okay, so we got that. All right, so it looks like we have 12 plus 3 ln 3. Okay, and then we have minus 4. Okay, we got that, of course, going to 0, and then finish that up. It looks like we're going to have 12 minus 4 is going to be 8. Plus 3 ln 3 should be the final answer to that problem. And that's an exact answer. Now, if I went ahead and got a decimal as an approximation on this, what I would end up having, I'm going to use that because I'm going to do something on the graphing calculator in a minute. So if I do 8 plus ln 3, oops, that's, I can't tell if I put the right thing in there or not. I guess I did. Oh, I forgot the 3. So 8 plus 3 ln 3, and that's, whoop, oh, well, what did I do? No, didn't put anything in. 8 plus 3 ln 3. All right, now we should be good. So that looks like that's approximately equal to 11.29583687. So let's keep that in mind, because what I'm going to do now is just show you how to check the answer to this problem graphically now. Okay, so I'm going to go up here now, and I put this in the graphing calculator. Let me go ahead and do this together. I've got x squared plus 2 divided by x minus 1. The window I'm going to do on this, since I'm going from 2 to 4, I'm going to go 0 to 6. I always like to go a little lower and a little higher. Scale of 1, and then I just sort of play with the y min, negative 10 to 10. So if you get your window set up like that and type graph, you'll have this. Now, let me go through and do just one thing here real quick. Let me do something with the window. I'll go back and adjust that so it'll just graph, okay? All right, so here's the graph that you should be coming up with. And again, on my handout, this is going all the way. This is 1, 2, 3, 4, 5, 6, going up to 10 and going down to negative 10 like that. So what we're doing is we're going to be doing the shaded region from 2 to 4. So we're finding the area bounded by the x-axis and the curve from 2 to 4. Okay, and the way you can do this on your calculator is you go second trace to open up that calc menu. You go to option 7. Okay, then the lower limit is 2. The upper limit is 4. Type enter and then it'll start shading. I think that's just so incredibly cool. All right, now that gives 11.295837. Well, that matches with what we got here, see? Okay, so we're good. All right, so you can use your calculator to check and verify. Okay, so that's a pretty good example of when you use long division. I'm going to go to one more example and do a similar idea with this. Okay, with this one, again, the degree of the top is 3, the degree of the bottom is 1, so long division might be a good idea. Again, if you split this up and did t to the third over t plus 1 and did that integral, you would have a hard time doing that integral, although you wouldn't have any trouble at all doing that integral, because that's a natural logarithm integral. Okay, so we're going to do long division. Now this time, we got two ways we could do this. So we can do t to the third, and I'm going to put in a 0t to the second plus 0t minus 2, just kind of for placeholders. And I got t plus 1 like this, okay? I'm going to go ahead and do it this way. And when I do this, I've got t to the third divided by t is t squared. Okay, so I got that. T squared times t is plus t to the third. T squared times 1 is plus 1t to the second. You can subtract. T cubed minus t cubed is nothing. This is 0 minus 1. So that's negative 1t squared. Bring down the next number. Then you do t squared divided by, or really negative 1t squared divided by t is negative t. Multiply. Negative t times t is negative 1t to the second. Negative t times 1 is negative t. Okay, subtract. Negative 1 minus negative 1. That's sometimes I tell students just change the signs. And then this is going to be 1t. Bring down the minus 2 now. And divide. So t divided by t is 1. And then 1 times t is t. And 1 times 1 is 1. Subtract. Again, I'll change the signs. So that will give what looks to be negative 2 minus 1, or negative 3, like that. Okay, so that's one way you could do this. I wanted to do synthetic division also, because if you divide by, in general, like x plus or minus some number, some constant a, if you have that structure, you can use synthetic division. So let me just kind of go through that. Then I'm going to have to erase all this and show you what to do then. So I'm going to go 1, 0, 0, negative 2. And when you do synthetic division, the structure of this is t minus negative 1. So you're dividing by negative 1. And again, you want to have placeholders. That's why I'm doing the 0. So in synthetic division, you bring down the 1. Multiply, that's negative 1. Add, that's negative 1. Multiply, that's 1. Add, that's 1. Multiply, that's negative 1. So you have a remainder of negative 3. Okay, like this. So what does this mean? This is, you divided t cubed by t, so that represents t to the second, minus t, plus 1. Those are what those constants are. And then if you have a remainder of negative 3, you say minus 3 over that divisor, like that. So those are two approaches to doing long division. So what I'm going to do is I'm going to write this integral as, we're going to look at the integral of t squared minus t plus 1 minus 3 over t plus 1 dt. All right. Now I'm going to go ahead and erase the division so I have room to do the integration on here. So I'm going to erase this long division. And you can do it either way. Synthetic division is certainly a little bit easier on this problem. So we got that. All right, that's generally stuff that you learn in pre-calculus or college algebra. Okay, so now we can do all these integrals. Okay, we can do the integral of t squared. We can do the integral of t. We can do the integral of 1 of a constant. And then I can bring the constant out and write this as dt over t plus 1. And I can easily do this. So this is a power rule integral, so that's t to the third over 3. Another power rule integral, so that's t to the second over 2. That's t, because the derivative of t is 1. Then this is a natural logarithm, so that's going to be 3 natural logarithm of t plus 1 plus c, like that. Okay, so what we'd end up having then is, I'm going to write this as 1/3 t to the third minus 1/2 t to the second plus t minus 3 ln t plus 1 plus c, and then this should be the solution to the problem then. Okay, so that's an example of how long division comes in handy, because if you break that up, then you have some pretty simple integrals, so you don't have to do U substitution on.